All right, ladies and gentlemen, today we're going to be combining the gas laws that we've learned so far. So we have Boyle's law, Charles' law, and the Gay-Lussac's law. Pause the video, write those equations down. I'll give you a second here. All right, now that you've played the video again, here we have P1 V1 equals P2 V2 is Boyle's. Charles' law is V1 over T1 equals V2 over T2. Gay-Lussac's law is P1 T1, P1 over T1 equals P2 over T2. We're going to combine those with the combined gas laws. So we're going to put those all in the same equation. We have V1 P1 over T1 equals V2 P2 over T2. So we're going to relate pressure, volume, and temperature as opposed to just a pair of each of those. So first problem we're going to do in the notes today, find the volume of a gas at 57.4 degrees Celsius and 1.75 bar if it has a volume of 22.31 liters when the temperature is 85.1 degrees Celsius and 1.22 atm. First thing we're going to do is we're going to separate the problem at the if, at the preposition. So we have our 1 and our 2 separated there. Next, what we're going to do is write down what we're looking for. So we're looking for V1 because it's in the first half of our equation, looking for a volume. We're going to write down the rest of our variables that we have. So P1, V1, T1, V2, P2, and T2. Take those right out of the problem. So in the first half, we have 1.75 bar as our pressure. We have 57.4 degrees Celsius as our temperature. Then we move on to the second half of the equation, and we have V2 is equal to 22.31 liters, P2 is 1.22 atmospheres, and T2 is 85.1 degrees Celsius. We don't like to use the unit of Celsius, so we're going to convert those into Kelvin by adding 273 to each one of those. Then we also have an issue with our units of pressure. So we have bar for one and atmosphere for the other. So we need to convert one of them. I chose to convert bar to ATM. You can choose to do ATM to bar. It doesn't really matter as long as they're the same units at the end. So 1 atmosphere is equal to 1.01325 bar. Get that equation going. We get 1.73 atmospheres for our P1. Next thing we need to do is set up our equation. So we have our V1 P1 over T1 is V2 P2 over T2. Have to rearrange. So we're looking for V1. So we're going to pull our equation down. We're going to move T1 from the bottom up to the top on the other side. Then pull our P1 from the top to the bottom of the other side. Now we have our setup equation of V1 equals V2 P2 T1 divided by T2 times P1. Going to write down our variables that we are given in our problem. So we have V1 is equal to 22.31 liters times 1.22 atmospheres times 330.4 Kelvin. We're going to divide that by our bottom, our T2 and our P1 are 358.1 Kelvin and 1.73 atmospheres. Plug that into our calculator, get the number of sig figs. After we cancel out our units, we're going to find is liters. Plug that into our calculator, get our sig figs of 14.5 liters. That's our final answer. So the volume of gas at that temperature and pressure is 14.5 liters. Next one we're going to do together in class. Write this down in your notes. We're going to do this one together as well. Write that one down. And then this one we're going to do with the partner. Write that down in your notes as well as this one. That's all we have for today. We'll see you in class.